Hello everybody, welcome to my first tutorial on how to make vanilla shaders in Minecraft. Today I want to explain how to use the posteffect command. It was added a few snapshots back, and I already made a video on what you can do with vanilla shaders, but as you can see this creation was like a year ago, and a lot has changed since then. Namely, this comment was added. And I'm sure many of you already played around with it in your worlds, or at least watched someone do it. Like you can type /posteffect add s, and then you already get a bunch of suggestions like a blur or a spider. And also you have to be careful in the most recent snapshot. If you don't fix it, this crashes your game, so don't actually do this unless you update like in a week from now. But yeah, this is the kind of stuff you can do. You can invert the screen, and as you can see, you can also stack all of these effects. But this far, I think most people already understand how to do this, but they don't really understand how do I actually add these effects, and that's the interesting part, or at least where do these effects come from. So I set up this new workspace in Visual Studio Code. Let's zoom in a bit so you can see more. And you can see I set up an empty resource pack without any files in it, just the folder structure. And I also unzipped my Minecraft jar. If you don't know this, inside your versions folder in .minecraft, you can, like right here, in your .minecraft folder /versions, you can see your Minecraft jar and just unzip this like a regular zip file, and you get this assets folder. And this is basically the default resource pack that the game uses. Like when you go into the resource packs menu, it's loading, yeah. This default resource pack, it's just that. And in here you can see all the shaders and post effects. And this list might be familiar to you, because this is exactly the same files that also show up inside the posteffects command, like right here. These are the same files, and this is also how you add your own. Like, let's look at invert.json, because this one's pretty simple. Let's just copy that into our own resource pack, right here, and rename it to something different, so it shows up as a different option instead of overriding the default file. So let's call this my custom effect. Alright, and now I can reload my resource packs. Alright, now I reload it, and I can type /posteffect add s, and you can see my custom effect is created, and it does the same as the invert effect because I just copied over all the code. So now this is basically all you need to do to add your own custom effects, but of course this isn't interesting if you don't know how to change what it does. So let's go through what it actually does. Like, the anatomy of this file is, it first defines a bunch of targets. A target is just like a location to store an image in. So you have this Minecraft main target. This is just the rendered screen, and then this custom target, this just does nothing, but you can output into it. And this is where we get to the second part of what this file is made of, and that's the passes list. The passes list is just a list of different instructions that you give to the game, that it runs from top to bottom, and basically one pass calls one shader, and this shader has access to some inputs and overrides some output, and then the output of what this shader renders is written onto this buffer. And in this case, swap just contains whatever the invert fragment shader drew, and now it's inside of swap, and then the second pass renders, and this time it calls the fragment shader blit, And here it reads from the swap target and outputs back into Minecraft main. So this split shader is just a shader that does nothing. This is a bit difficult to understand with just the code. So this reads from invert and writes to swap, and this reads from swap and writes to main. And I just drew this picture that basically explains what's going on. So main is just the input to the whole shader, and then it calls the invert.fsh shader program to write into the swap target, and then it calls in the second pass the blit.fsh shader and writes from swap back into Minecraft main, and this is also the output of the shader. And the idea is invert.fsh contains our actual logic that we need to invert the screen color, and bit.fsh is just a program that does nothing, so it just copies straight from swap into main. And the reason for this is main needs to be our output, and we can't have main as both the input and output of the same pass. So we need to introduce this second pass that copies from the output of this first one back into the output that we actually wanted in. I just used this word fragment shader. It also says vertex shader right here. You might be wondering, what does this even mean? In the context of post shaders, the vertex shader is mostly useless. The vertex shader is just responsible for stretching one triangle across the whole screen, and then the fragment shader does the interesting stuff where it calculates the actual colors that are output to your screen. So for this reason, I'm just going to ignore the vertex shader for this tutorial. You can just always use this screen quad shader if you're going to use post shaders. And maybe for future tutorials I will explain more about what vertex shaders are. So for the fragment shader, the big mystery is, how does this work? Do you just have to take the ones that are provided by the game? And well, the answer is no. You can write your own ones. And the locations where this looks up at is just inside the shaders folder inside the resource pack. Right here it says post subfolder, so I'm looking inside here, and here you can see invert.fsh. FSH just stands for fragment shader. So here, for example, you have a VSH. This would be the vertex shader, but as I said, we are just ignoring this for now. So looking inside the invert.fsh, you can see a lot of different logic. Most of it you can ignore, and actually most of it actually doesn't even do anything. So for the sake of the tutorial, I'm just gonna delete it from the file, and nothing actually changes about what it does. Okay. So with this, it's pretty easy to explain what this file does. Like you can see it declares some stuff at the top, like the in-sampler, that's just the input that we already defined in the JSON just now. Like right here, it says sampler name in, and then it just adds sampler to the name, so it can be distinguished from other stuff. And then you have some other inputs, like the texture coordinate for the current pixel, and an output that's just the color for the current pixel. And then you have this main function, and this main function is just the entry point for the whole file. And here the idea is the main function runs one time for every pixel on your screen, because this is a fragment shader. And now you have this these different variables. First is diffuse color. This is just a random variable. It also doesn't need to be called with diffuse color. I don't even know why diffuse is the common word. I'm just going to rename it to just color, because this is the color of the screen at the current pixel coordinate, because well, that's how this texture function works. It just takes some sampler and some coordinates and returns the color at those coordinates. And well, then it calculates the inverted color, that's just 1 minus x, and notably this color is in the range from 0 to 1, so 1 is the maximum, and well, this is how the inversion works. And then it just outputs this to the screen by writing to this frag color variable. And that's how this whole effect works in Minecraft. And well, I don't want to edit everything in the default resource pack, so I'm reverting all my changes. Okay, and going to my own resource pack and making a new FSH file. So custom.fsh, I'm just gonna call it, and I just copy over all of the code from the default file and save this. And now I want to change the JSON so that it points into my custom file. All right. And now let's change this up. So I already explained this whole thing runs one time for each pixel, and maybe let's visualize this. So textchord.xy for clarity. So this is basically the simplest shader that you can have. This just outputs as the red component text coordinate.x, as the green component text coordinate.y, and then 0 for blue, and then 1 is the opacity, and this is just fully opaque, so this doesn't actually change anything. However, let's save this and let's try to predict what this does. And maybe, well, hopefully you can already guess. Well, it's going to reload for a bit. Alright, and this is the result. I don't know if this is what you expected, but basically for every pixel coordinate it just displays on the red channel how far along the x-axis this is, and on the green channel how far along the y-axis this is. And this is basically all the logic that you have inside a shader. Everything else is just what you do with these coordinates using math. So you can, for example, multiply these by 2, and now everything is going to look a bit different, but mostly the same. So now you can see everything is a bit brighter, and it just takes half the time to go from fully black to fully red or fully green, and then for the rest it just stays fully red because it's larger than 1. And while using this, you can already do some simple shapes, like when you go back to just this, you know that 0.5, 0.5 is in the middle of the screen, so maybe you can subtract that. And now you have everything centered around the around 0, 0, and maybe you want to know how far something is away from the screen. So let's just use this as the red component and set blue and green and blue as 0, and maybe get the length of this vector. And this basically gives us the distance of the current coordinate to the center of the screen. And we can also draw this in Minecraft. Alright. And now you can see in the center of the screen it's fully black, and then it gets more red over the progress of the screen. And using this, you can also already make a simple post effect, like we already made one, but one that actually makes sense for what we are trying to do here, like something that you can actually use in game. And basically what you can see is this looks like some vignette effect, like maybe you take some damage and then the screen border looks dark, looks red, but the problem is in the middle it looks completely black, and we want to see like I'm moving my cursor around and I don't see the word anymore. So let's add back the part where it reads like the in-sampler, like the screen color. So vec for color equals texture in sampler text coordinate, and let's also put this into our own variable like vec3 vignette color equals this length, and or actually let's just set it to red and put it as a vec4, and you're gonna see why. Now I can mix the color and the vignette color using this built-in mix function. Which way around? Color, vignette color, and then we can put a third variable that just tells us how much we should take of this and how much of this, and paste in this expression that I wrote earlier. And also I have to multiply this by 2 and put color.rgb right here. And now I can try this out. And you can see right in the middle of the screen, we see the regular game, and on the edges we see everything is red. Maybe multiplying everything by 2 wasn't the right choice. Reload again. Alright, now it's more subtle. Like this variable just goes from 0 to 1, like 0 in the center and 1 in the corner. And when it's 0, it chooses this screen color, and when it's 1, it chooses this red vignette color. And with this, we've already made a simple post effect. And as you can see, I can clear this and add it back again. And this is very easily toggleable. And you can also do some other crazy stuff. Like, for example, let's not change the result of this lookup, but let's change the input. Maybe you can say text coordinates equals 1 minus text coordinate. I'm not actually allowed to do this because text coordinate is an input, and we can't change inputs. So let's make a temporary variable, like call it uv, and replace text coordinate with uv everywhere. All right, and let's see what this does. And as you can see, if you flip the uv, it flips the whole screen as an effect, because originally it's sampled the texture coordinates 0, 0 at the bottom left corner, but now 0, 0 becomes 1, 1, and it samples right here on the main screen. So that's how you can easily flip the whole screen. And actually, when you look inside the default shaders, it's... oh wait, it doesn't do that. That was like a couple of years ago when the default resource pack had a flip shader. Whatever. So this is pretty trippy when you tried it out yourself. But this is how you can do a bunch of crazy stuff. You can also like square the whole UV, like UV equals UV times UV. You can play around with this stuff and do a bunch of crazy things. And now it looks very distorted. And basically you can enter any mathematical function into all this. And this is where I'll stop using Minecraft for a moment, because you already have a bunch of resources on shadertoy.com. Like, let me go to the main page and see a bunch of the crazy shaders that people did. Why does it load so long? Let's just look at my own shader for a bit. So this is the shader that I wrote a while ago, and you can see you can define your own textures at the bottom. This is basically my replacement for this in sampler, and this has its own main function, and you can see I define my own UV coordinates, like just like I did right here, and then it does like a mathematical function that outputs a screen color, and then and this also has an opacity, and then I mix the texture that I read from this sampler. I mix this texture with the color that I output right here, and the opacity that this function outputs. And in here I'm doing basically a bunch of math to add this prettier vignette effect. And actually I can actually copy all of this into my own post effect. And I'm also using some global variables. So I have to write include Minecraft globals.glsl. Basically what this does is inside the default resource pack there are some include files, and we can copy and paste those into our own codes by using this include directive. And you can see right here the globals file defines all these different uniforms. Those are like global variables. And you can see right here we have the screen size and the game time. And I'm using this in this code, so this is why I have to write this. I copy pasted all of this. I have the UV defined right here, and I have to paste this as well. Alright, and iChannel is bad in sampler is right. And now let's see what happens. Okay, and we have this nice effect. Maybe in the next tutorial I'll do a bit of an explanation of how you write this kind of stuff. There also are a lot of existing tutorials on how to write shader toy. Maybe I'll link them. Maybe I just look them up right here, like Inigo Piles. This is basically the Bob Ross of shader toy. He's also the author of this whole website. And you can see, like 1 month ago, he made a tutorial of how to do this 3D well pillar in shader toy. And he basically does a bunch of 3D stuff. For a bit of more of an introduction, maybe look at the art of code. Here's a bunch of beginner tutorials on shader toy. This basically has everything you need and a bunch more on how to create an effect like this. But yeah, maybe I'll do my own tutorial on how to make this, just for completeness sake, so you don't have to switch between different channels. But if you already know this, you can basically skip my explanations on how to do that. And this is basically all I wanted to say on the basics on how to use the post effect command. I hope it's very understandable, like what this does. Maybe you don't understand everything about the code yet, but this is basically a long journey. There's a lot you can improve. I'm not even perfect on this, even though I've spent a lot of time on this. I have a lot to improve on. And basically, you can tell this just by the fact that he made a tutorial playlist and it has 53 videos. Like, there's a lot you can learn. The ceiling is very high, but as you saw before, it was very easy to make a very simple effect, and people have already been doing a lot with it. So, I hope you follow along with my future tutorials. I'm not only planning to do shader toy tutorials like this is just a small part of what I'm trying to do. We can also go back to the other video that I showed at the beginning, like how to integrate this stuff into Minecraft. Like, not just doing this as like a static image over the screen, but being able to have it inside your world. This is basically what I'm planning to do from now on. Another part that I'm trying to do is not just explaining these post shaders, but explaining the core shaders. These are a very important part of how to do shaders in Minecraft. Basically, as a small teaser, the core shaders are what the game uses internally to render blocks inside your world, to render the sun inside your world, to render your inventory, to render everything you see on screen. So this is all stuff you can then directly tinker with, like changing which texture is used on the block, but well, I'm getting ahead of myself. I hope you are motivated to tune into more tutorials. I'm motivated to make more. It's probably going to take a few days, but see you next time.